Today I would like to talk about the intermediate value theorem, and specifically I want to talk about how it can be useful to show us where a polynomial can actually guarantee to have a root. I'm going to first show you an example specifically, and then I'm going to explain the concept of this. So if I were given this polynomial and I were also told that there is a 0 somewhere between 1 and 2 on this polynomial, I'm using interval notation here. For you to show this, all you simply need to do is you need to calculate f of 1 first. Let's go ahead and plug that into the function. So when I plug that in, let's go ahead and see what happens here. I'm going to plug in the value 1 into this, and when I simplify this, this is going to be 2 minus 12, which is going to give me a value of negative 10. So in other words, I could write f of 1 is equal to 10. I'm going to go ahead and put that in a red box here because that was my f of 1 value. I'm going to go ahead and shrink this down a little bit here. Move this over to the corner here. Now what I would like to do is I would like to look at what happens when I plug in 2. Let's go ahead and talk about f of 2. I'm going to go ahead and plug in 2 into this function here, and I'm going to have 2 something to the third power. What something is that? I'm going to go ahead and plug in the number 2. When I plug that value in here, I'm going to get 8. I'm going to end up with 16 minus 12, which is going to give me a value of 4. In other words, I can write f of 2 actually equals 4. I'm going to go ahead and put this in a box here. And what I want you to recognize here is that the sign on f of 1 is negative, and the sign of f of 2 is positive, and therefore when we pass from negative to positive, you must have a 0 in between. That is what the intermediate value theorem guarantees. Graphically wise, you can look at it like this. So for example, here's my axis very quickly here, and I'm going to be at 1 and 2. You'll notice f of 1 is a negative value, so I have some points down here that's negative, and f of 2 is a positive value, which is up here. Your polynomial must pass from that negative value to that positive value. In other words, it must guarantee a 0. When you write this up, you want to make sure that you say f of 1 is negative, f of 2 is positive. Therefore, the intermediate value theorem will guarantee that that polynomial, because it is continuous, will pass through a 0.